Acceleration is only produced in the direction in which the force acts. Regardless of its initial motion, gravity will always pull something towards ground. If someone was to run off a cliff with a steady horizontal x-axis speed, the speed would not be changed. Only the vertical y-axis speed would be changed, because that is where the force gravity is acting upon. Is Spiderman's web really strong enough? If Spiderman swings in an arc, the web must apply an extra force in addition to his weight. This is explained by Newton's second law of motion, which tells us that a force is needed to change an object's motion. A change in motion, acceleration, is either a change in magnitude or a change in direction. No force would be equal to uniform or constant motion. In order to change the direction of motion, an external force is needed to act on the object. If Spiderman swings, he does so in a semicircular motion. This means that even if the magnitude of his speed, how fast or slow he goes, does not change at all during the swing, the direction is constantly being changed in order for it to be semicircular. As we said before, a change in direction can only be caused by an external force acting upon the web, which in this case would be the tension from the webbing. The webbing must then supply two additional forces, one to support Spiderman's weight and prevent the web from snapping, and the other one to be constantly changing his direction, which would be an external force acting upon his acceleration. The velocity of an object constantly traveling along a circular trajectory can be found by the formula for the centripetal acceleration, velocity squared over radius. If Spiderman is swinging from a web that is 200 feet long at a speed of 50 miles per hour and the centripetal acceleration that is given is 27 feet per second squared, in order to find his centripetal acceleration, first we would have to convert miles into feet and hours into seconds like so. 50 miles times 5,280 equals 264,000 feet. 1 hour equals 60 minutes times 60 equals 3,600 seconds. 264,000 feet over 3,600 seconds will equal 73.48 feet per second. Another way you could find the centripetal acceleration is using the formula the initial speed equals square root of acceleration times radius, in which case the initial speed equals 27 feet per second squared times 200 feet. The initial speed equals square root of 5,400 feet squared over second squared. The initial speed would equal 73.48 feet per second.